Hi friends, we have to discuss about the topic Gauss Elimination Method. The Gauss Elimination Method, also known as row reduction method. It is an algorithm in linear algebra for solving a system of linear equations. This method can also used to find the rank of a matrix, to calculate the determinant of a matrix, and to calculate the inverse of an invertible square matrix. The method is founded by a German mathematician named Carl Friedrich Gauss. There are three operations in Gaussian elimination method, that are: first one is swapping two rows, then the second multiply a row by a non-zero number, and the third one is adding a multiple of one row to another row. Then next move on to the steps in detail.
The Gauss elimination method is characterized by step-by-step elimination of variables. Step 1. Write the augmented matrix corresponding to the linear system. Step 2. Interchange rows if necessary to obtain an augmented matrix in which the first entry in the first row is non-zero. Then pivot the matrix about this entry. Interchange the second row with any row below it if necessary. Row reduced form of a matrix. Each row consisting entirely of zeros lies below all rows having non-zero entries. The first non-zero entry in each non-zero row is 1. In any two successive rows, the leading one in the lower row lies to the right of row reduced form of a matrix. Each row consisting entirely of zeros lies below all rows having non-zero entries. The first non-zero entry in each non-zero row is 1. In any two successive rows, the leading one in the lower row lies to the right of row operations. First operation. Interchange of any two rows. The notation is like that. Ri interchange Rj means interchange of row I with row j. Operation 2. Replace any row by a non-zero constant multiple of itself. Cri means replace row I with c times of row I. Operation 3. Replace any row by augmented matrices. Matrices are rectangular arrays of numbers that can aid us by eliminating the need to write the variables at each step of the reduction. For example, the system 2x plus 4y plus 6z is equal to 22, 3x plus 8y plus 5z is equal to 27, minus
The Gauss elimination method can be expressed with matrices rather than the system of equation. So the solution for the system of equations can be found by arranging it as augmented matrices. By rearranging the rows, we can find the number of solutions for the given system of equations.
Here, Aisha explained how the Gauss elimination method works on a system of linear equations. So, now I am going to speak about the program algorithm. The algorithm, after the compiler completes compiling, the program is started. Then we declaring the precision and variable that we want. After that, we giving the input as the value of the augmented matrix. On that, Gaussian elimination is performing. Then it prints the matrix after the elimination is done.
Hi friends, now we are going to see how to create a C++ program for Gauss elimination. The first part of the program is a header. Next comes declaring of variables. The 7th line is used for setting the precision. That means to set the number of digits after decimal point. Since here it's given cout precision 1, after decimal point 1 digit will be visible. For example 2.5 etc. Then comes cout enter the number of equations. We can enter the number of equations and it will be stored in the variable n. Next we are declaring argument matrix and variable matrix like float a, n and n plus 1, and n plus 1 is an extra column for the constant values. Then x of n is for the values of the variables. Next line is cout enter the elements of argument matrix row wise. So we have to give the input in row wise and it will be stored in that array. The next part of the program, that is from line 16 to 24, is used to arrange the equations in order to obtain a reduced row form. For example, if the first coefficient of the first variable of the first equation is 0, it isn't possible to get a row echelon form. So we have to rearrange with the adjacent row so that we can obtain a reduced row form. In line 16, for I is equal to 0, I less than n, I plus plus. So I starts from the first row. Then for k equal to I plus 1, k less than n, I plus k plus plus. The k starts from the next row after I. Then if ai less than aki, it checks whether the above element is smaller than the one below, and if it's true, the whole row gets swapped. Same as what we do in the row interchange option. The loop continues and at the end we'll get a rearranged matrix which is then used to perform the Gauss elimination. The next part, that is from line 25 to 31, is used to perform the Gaussian elimination to get the reduced row form. For I is equal to 0, I less than n minus 1, I plus plus, and k is equal to I plus 1. That is from next row onwards, k less than n, k plus plus. Next we initialize a variable t to obtain by what factor the element above is greater than the element below, in order to make the element below 0. This operation is same as the operation 3. Since every element in that row has to be changed, a for loop is used. The next part of the program is printing the matrix after Gauss elimination. It is same as printing a 2D array. The next part of the program, that is from line 40 to 47, is back substitution. For I is equal to n minus 1, I less than or equal to 0, I minus minus. Since it's back substitution, we will start from I n minus 1 to 0. For example, consider n equal to 3. I equal to n minus 1, so I equal to 2. Now x of I equal to ain. So x of I means third position, that is the value of variable 3 is equal to the value of in, that is 2, 3. That means the constant value. So the constant value will be saved to the value of the variable. Now for j equal to I plus 1, j less than n. I is 2, so j will be 3, j less than 3, it becomes false and directly goes to the next statement. So x of I is equal to x of I divided by a of I. That is x of I means the constant value divided by the coefficient. So we'll get the value of the variable. Similarly, in the next iteration, the value of I becomes 1. Then x of I equal to ain, that is the constant of the second equation will be saved to the second variable. Then for j is equal to I plus 1, j less than n, j plus plus. So j will be equal to 2. and which is less than 3. It becomes true and gets inside the loop. If j not equal to I, j is 2 and I is 1, so it's also true and it gets inside the loop. Next, x of I is equal to x of I minus aij into x of j. That is, the value of the second variable is equal to the value of second variable, that is the constant we have saved, then minus the coefficient of the third variable into the value of the third variable, and this value divided by the coefficient of the second variable gives the value of the second variable. Similarly, in the next loop, I will be equal to 0. It continues in the same way and we'll get the value of variable 1. This part is a bit confusing one, so try substituting values so you get to know how it works. The final part of the program is to print the value of these variables.